Simple harmonic motion is equal to any motion where a resistance force is applied and is proportional to the inverse movement of the system. It is the same as uniform circular motion. If we take the circular motion in x direction, the movement looks quite like a spring having the same acceleration, means that the radius of the circle is the same as the amplitude of the spring. Our objective is to build a setup that can oscillate a mobile device along a single axis, using an accelerometer to record data with the oscillometer and plot the acceleration as a function of the time. With this information, we will try to find parameters such as maximum acceleration, maximum velocity, spring constant, period, and frequency. First of all, we record the data with the app. It shows us the index, the x-axis, the y-axis, and the z-axis. Then we migrate the information to an Excel document. The only problem was that the information recorded was missing the gravity constant. By multiplying all the columns by the gravity, we'll get the new information which we will graph. The results are the following ones. Now, to get the graph of acceleration, we will modify our index on our column X. Each 10 index information files will give us a second of information, so we will divide the index over 10. By graphing the new information obtained, we will get the graphic of acceleration. Now we can proceed to understand the theory behind this. To get the maximum experimental acceleration, we get mean of the peaks of the graph we obtain. Now, analyzing the formula of the acceleration and getting the maximum acceleration, we can say they are the same. Now, to get the W, we use the revolution per minute. A complete revolution will be 2 pi, and it takes a second to complete one, so the W is 6.28 radians per second. Additional to that, now that we know the W and the mass of the cell phone, we can obtain the spring constant by multiplying m times W squared. The period it takes to complete is 1 second. By dividing it over 1, we get the frequency, that will be 1 Hz. Finally, this information will help us to get the total energy, that is the spring constant K times amplitude A squared over 2. This will give us 0.5023 joules.
We could obtain these conclusions. Inside the graphic of position, the displacement is n over 2 respect to the velocity. We don't have the velocity at its maximum displacement. Also, the maximum velocity is the equilibrium point because it's where Vmax is equal to W times A. This means angular velocity times amplitude. Also, the sign indicates the direction of the movement. Another amazing discovery is that acceleration has the opposite direction against the position. It is forced to cancel exactly in the middle of point of the equilibrium. Also, the maximum acceleration is located at the farthest trajectory of the movement, acting as maximum acceleration equals to amplitude times W squared.